There's ash all over the camera! Use the force!
No, I can do this. I know my house perfectly. I can do this with my eyes closed.
Don't break anything!
Trust me, I got this.
As we can see here, many things can go wrong when piloting a drone remotely. In addition to the unfortunate camera mishaps and reckless piloting pictured in this movie clip, GPS technology is imprecise in determining the drone's location, connectivity issues can cause problems when the drone is out of range, and environments, particularly outdoor environments, are constantly changing. These challenges in understanding, mapping, and navigating an environment are some of the motivating factors for why our team of 4, Maggie, Nitsan, Shuba, and Wayan, chose to work on our project, OpenARK drone-based 3D reconstruction. Our ultimate goal was to develop, implement, and evaluate a robust system to conduct 3D reconstruction outdoors on a drone and in real time. Now I will talk a little bit about the design of our system. After doing some research, we found that the Z2 stereo RGBD sensor was best suited to our purposes. From this camera, we get both the depth and color output, and it's particularly suited to work well for outdoor settings. With each and every frame, we grab the RGB image, depth image, IMU, and timestamp. And these are input into our SLAM and 3D reconstruction algorithms. Next, we stream all of that data from our onboard drone computer. We ultimately choose to use GStreamer for our streaming, but currently we're using the Z API. We are using the Jetson NX as the on-drone computer, which is very lightweight, which is a reasonable cost, and worked very well for our purposes. We're streaming this data to a very powerful server which is on site, and we're going to be using this server to run our 3D reconstruction algorithm. Lastly, we pipe all of this data into OpenARK, with which we conduct our 3D reconstruction algorithm. OpenARK is an open source augmented reality SDK developed at the FHL Vive Center for Enhanced Reality, and our team sought to adapt the existing 3D reconstruction software pictured here to the drone-based use case. Now for a bit about our process. We set up 2 pipelines to compare our outputs, and one uses OpenARK's 3D reconstruction, while the other uses Zed's 3D reconstruction. Now for our final day of the demo, we designed, 3D printed, and installed these custom-made mounts for both the camera and the Jetson NX. This is what our drone looked like on the day of. And lastly, we got all set up to test out our 3D reconstruction at the Richmond Field Station. Now for our final demos. Let's start off with OpenARK. So here is the reconstruction conducted on OpenARK with footage via a drone. Currently, offline 3D reconstruction provides a good quality mesh and the ability to conduct 3D reconstruction on saved data. Our online 3D reconstruction algorithm provides lower quality meshes, which is by design, and is currently in the works for some improvements. Lastly, here is the demo for Zed's built-in 3D reconstruction, so we can compare outputs. As we can see here, Zed has a slightly different way of showing the mesh being created overlaid on the actual video footage from the drone. And finally, here is the resulting 3D reconstruction output using Zed's built-in SDK. For future work, we're interested in improving our offline 3D reconstruction algorithm and actually using these meshes in a VR setting. Thank you so much for listening, and we'd be happy to answer your questions in the chat.